You never actually tell Kubernetes to start a container. You don't hand it a list of steps. You hand it a file that describes the world you want. 50 copies of this service reachable at one address, always up. Then a piece of software reads that file every few seconds, looks at what's really running, and quietly fixes the difference. Then it does it again, forever. That software runs 82% of the containers in production today. It came out of Google, it turned 10 in 2024, and most engineers who touch it every day couldn't draw its architecture. By the end of this, you can. I'm at pattern repetition. Let's get into it. First, the problem it was actually built to solve, because containers on their own don't get you there. A container packages your app with everything it needs to run. One command, one box, done. That's fine, until you need 40 of them spread across a dozen machines. Then one machine dies at 3 in the morning. Who restarts those containers? Who tells the load balancer they moved? Docker Run has no answer for any of that. You could script it yourself. Teams did for years. Some bash, a health check, a cron job that restarts things when they fall over. It holds up right until the edge case. A deploy half finishes. 2 scripts grab the same machine at once. The pager goes off and the fix is always more script. That's the tar pit Kubernetes was built to drain. So here's the shift that changed everything. Stop giving orders, start naming the destination. The word for it is declarative. Imperative means you spell out the steps. Declarative means you state the end result and let the system work out the steps. You don't say scale up one pod, then check, then add another. You say I want 10 and Kubernetes works out how to get from 3 to 10. Underneath, a control loop runs and never stops. It reads your desired state. It looks at the actual state of the cluster. It compares the two. If they don't match, it acts to close the gap, then starts over and checks again. This loop has a name, reconciliation, and it is the single most important idea in the whole system. Picture a thermostat. You set it to 70 degrees. It doesn't run the furnace on a timer. It reads the room and drives it toward that number, then holds it there. Kubernetes is a thermostat for your infrastructure. You pick the target, it does the chasing, and it never gets bored. That loop has to live somewhere. Time to open the box and see the parts that move. A cluster splits into 2 halves. The control plane is the brain. At the center sits the API server, the front door everything talks through. Behind it, etcd, the store that remembers every object. The scheduler decides where new work lands, and the controller manager runs all those reconciliation loops. That's the half that makes the decisions. The other half is the nodes, the machines that actually run your containers. Each node runs a kubelet, the agent that starts your pods and keeps an eye on them, a kube-proxy that wires up the networking, and a container runtime, usually container D, doing the real work. The brain decides, the muscle runs. Burn one fact in. Only the API server ever talks to etcd. Nothing else does. Every component reads and writes through that one front door. Behind it, etcd leans on the raft algorithm to stay consistent across its copies. It's your single source of truth. Lose it with no backup, and the cluster is gone. The control plane speaks in objects. Learn 8 of them, and the whole thing clicks into place. Start at the bottom. A pod is 1 or more containers that live and die together, the smallest thing Kubernetes runs. A replica set keeps a fixed number of identical pods alive. A deployment wraps the replica set and adds rolling updates and rollbacks. Each layer quietly wraps the one beneath it. Here's what you actually write. A little YAML. Kind, deployment. Replicas, 3. A selector that marks which pods are mine. And a template describing the container to run Nginx version 127. Notice what's missing. No machine. No start command. You describe the shape and the cluster makes it real. But pods are disposable. They get replaced and every replacement shows up with a new address. So you put a service in front, one steady name and IP that load balances across whatever pods happen to exist right now. And Ingress sits above that, routing outside HTTP traffic to the right service by host name and path. 2 more you'll reach for constantly. A ConfigMap holds plain configuration, your settings, injected as environment variables or files. a secret is the same idea for the sensitive values. One catch worth knowing. By default, a secret is only base 64 encoded, not encrypted, unless you switch on encryption at rest. Put it together and you've met the core vocabulary. Pods run your code. Replica sets keep them alive. Deployments roll them out. Services and Ingress route the traffic. Config maps and secrets carry the config. And namespaces cut one cluster into separate walled-off worlds for different teams. Those are the nouns, now the verbs. How a pod actually gets placed and how it stays alive. You ask for a pod, the API server writes it into etcd with no node assigned. Scheduler spots it sitting there unplaced, picks the best machine and writes that choice back. Over on that machine, the kubelet sees a pod now assigned to it, pulls the image and starts the container. Nobody issued a direct order. Everyone just reacted to a change in state. So how does the scheduler choose? In two passes. First it filters, dropping every node that can't fit. Wrong resources, attained in the way. An affinity rule it breaks. Then it scores whatever survived and takes the top one. Filter for what's feasible, score for what's best. Now the payoff. I list the pods, 3 of them running. I delete one by hand. On a normal box, that pod is just gone. Here, I list them again a second later, and there are still 3. The replica set saw actual slip below desired and spun up a replacement. No page, no human. The loop simply did its job. This rewires how you think about servers. The old way, servers were pets, named, nursed back to health when they got sick. Pods are cattle. When one gets sick, you don't nurse it, you replace it. Don't SSH into a pod to patch it. Kill it and let the loop build you a clean one. Same loop, heavier lifting. It's the exact machinery behind autoscaling and shipping new versions. Scaling can run itself. The horizontal pod autoscaler watches a metric, usually average CPU, and nudges your replica count toward a target. Traffic climbs, it adds pods. Traffic falls, it takes them away. Out of the box, it checks every 15 seconds. You set the target. It handles the arithmetic. Shipping a new version runs on the same idea. You change the image and the deployment kicks off a rolling update. It brings up a few new pods and waits for them to go healthy. Then it retires a few old ones. It repeats until the whole fleet has turned over. 2 dials set the pace. Max surge and max unavailable. And a bad release? You don't scramble to rebuild the old one from scratch. Kubernetes kept the previous version on hand. One command, rollout undo, and it runs that same rolling process in reverse. The broken pods drain, the last good ones come back. Most teams don't appreciate that safety net until the night they actually need it. Let's hang some real numbers on all this. Starting with how big it goes. Kubernetes stopped being niche a long time ago. In the 2025 CNCF survey, 82% of container users ran it in production. That's up from 66% just 2 years before. 98% of orgs are doing cloud-native work of some kind, and 2/3 are already running generative AI workloads on it. How far does a single cluster stretch? The official design targets read like a ladder. 110 pods on one node. 5,000 nodes in a cluster. Stack that up and you land at 150,000 pods, 300,000 containers, all steered by one control plane. Almost nobody ever gets close. Here's the path it took. It grew out of Borg, Google's internal cluster manager, open sourced back in 2014. Version 1.0 shipped in 2015. Google handed it to the brand new CNCF as its very first project. It graduated in 2018, turned 10 in 2024, and today the current release is 1.36. Now the honest part. The bit the getting started guides tend to skip. So should you actually run it? Walk through a few questions. Do you have many services, not 3? Do they genuinely scale up and down? Is there someone to own the cluster day to day? All yes, and Kubernetes earns its keep. 2 containers on one box that barely change. That's a no, and you'll feel the weight. It's really a trade of complexity for capability. Down low, a single VM or plain deploy tool, easy to run, but it won't scale on its own. Up high, Kubernetes, huge power and a real operational tax. Docker Swarm and the managed platform sit somewhere in the middle. No free lunch here, just the right spot on the curve for you. And that tax is real, not theoretical. In one 2025 survey, 44% of teams walking away from Kubernetes named operational complexity as the reason. 67% of platform teams call it their single biggest bottleneck. The thing is wildly capable and it will cheerfully hand you a full-time job you never planned for. Kelsey Hightower, who taught a whole generation this stuff, said it best. Kubernetes is a platform for building platforms. A better place to start, he said, not the endgame. It hands you the primitives. What you build on top of them is still on you. So that's Kubernetes. You describe the world you want, a tireless loop makes reality match it, and then it holds the line. That's the whole trick, from a single pod all the way to 5,000 nodes. Use it when the scale is real. Skip it when it isn't. Either way, now you can draw the box. I'm at pattern repetition. See you in the next one.